There are discoveries that make astronomers lean closer to their screens. There are discoveries that trigger debates and late-night emails. And then there are discoveries that don't simply confuse us, they rip through the foundations of physics itself. The kind that makes senior cosmologists stop talking mid-sentence and stare at the data like it's a message from another reality. The kind that make Nobel laureates quietly murmur, "This should not exist." Because the James Webb Space Telescope has just delivered one of those discoveries. Not a minor adjustment, not a strange anomaly, but a revelation so disruptive that the standard model of cosmology trembles under its weight. Webb wasn't just built to look deeper. It was built to look earlier, beyond the fog of the cosmic dark ages, into a time when the universe was barely learning how to shine. We expected to see tiny, fragile gatherings of gas. Faint glimmers. Chaotic clusters still trying to become galaxies. The messy birth of structure. Instead, Webb saw something that should have been impossible. It saw galaxies. Real galaxies. Bright, compact, massive, mature. Galaxies that behaved like seasoned veterans of the cosmos, even though by the timeline of the Big Bang, they should barely have existed at all. These weren't the universe's first steps. These were long strides. Confident motions. Structures too heavy, too luminous, too organized for their age. And it all began with a single, tiny, unassuming blot of light. One faint dot tucked inside a deep field image. Nothing unusual, nothing dramatic, just another distant smudge. But its brightness was wrong. Not slightly wrong, catastrophically wrong. It was too bright to belong to the early universe. Too bright to be real. Astronomers assumed it was an illusion, a closer object masquerading as something ancient. But spectroscopy sliced through that hope in an instant. The redshift was enormous. The distance was real. The object truly existed only 290 million years after the Big Bang. And yet it looked like it had already lived for billions. That was the moment the quiet panic began. Because if even one galaxy could grow that fast, then something in the cosmic story was broken. And Webb didn't stop at one. More objects appeared. And then more. And then an avalanche. Massive early galaxies scattered across Webb's deep fields like cosmic landmines. Some too bright to fit inside the equations. Some too compact to be explained by gravity alone. Some so heavy they violated the limits of how quickly matter can collapse. A recent analysis identified 87 possible galaxies forming between 200 and 400 million years after the Big Bang. The number alone is unbelievable. The implications are worse. If even a handful of these are real, then the formation of galaxies did not follow the rules we thought were unbreakable. The early universe wasn't slowly building complexity. It was already structured. Already mature. Already behaving like a universe many billions of years old. As if we skipped the first chapters of cosmic history. As if the universe started in the middle of the story. But the next discovery was even stranger. Webb found ancient objects where nearly all the available gas had turned into stars. Not 10%. Not 50%. Not even 90%. All of it. Every atom. Every drop of gas converted into starlight with an efficiency that borders on the impossible. Modern galaxies can't do this. Physics doesn't allow it. Star formation is messy, lossy, inefficient. Yet the early universe seemed to be doing it flawlessly, like it was using a different recipe, a different kind of physics. Some astronomers propose that these may not be galaxies at all. They might represent an unknown category of structure, something that predates our models entirely. Something that belonged to an era we don't understand. Something older, stranger, and missing from our textbooks. And that was all. Then came the discovery that truly shattered the peace of theoretical physics. According to relativity, there is a hard limit on what we can observe. Galaxies moving away from us faster than the speed of light lie beyond a cosmic horizon. Their light should never reach us. They should be invisible forever. But Webb sees them. It sees objects sitting in regions of spacetime where, by every calculation we have, their light should not be able to escape. The universe shouldn't allow us to look that far back. And yet the images are right there, glowing on Webb's detectors. Sharp. Bright. Impossible. This means one of two things. Either relativity is incomplete, or the geometry of the universe is not what we think it is. Either spacetime behaved differently in the beginning, or our entire timeline is miscalculated. Every option is unsettling. Every explanation breaks something fundamental. The early galaxies Webb observes are not just too old. They are too evolved. They are too organized. They are too heavy for the universe's age. And the unavoidable conclusion starts to form like a storm cloud. These structures may have existed before the cosmic microwave background. Before the universe was transparent. Before the moment we treat as the beginning. Some of the world's leading physicists now say the quiet part out loud. The Big Bang may not have been the birth of the universe. It may have been a transformation, a phase change in a cosmos that already existed. If the universe is infinite today, perhaps it was infinite then. If it existed before the Big Bang, perhaps it existed forever. In that view, the Big Bang did not explode from a single point. It unfolded everywhere at once across an already infinite landscape. A shift in state rather than an act of creation. And Webb, with its golden honeycomb mirror, might be detecting fossil traces of a time before time. Clues from a universe older than the Big Bang itself. But the true mystery is still the nature of these objects. They do not behave like galaxies. They are not quasars. They are not star clusters. They burn with an efficiency that defies thermodynamics. They assemble at a speed that violates gravitational limits. They appear in places they should not be. They follow none of the known rules. They belong to a chapter of cosmic history we haven't written yet. And this leaves cosmology with two choices. Change the data or change the universe. But the data is solid. It is repeatable. It is consistent. Webb keeps seeing the same impossible patterns no matter where it looks. So the universe must change. The timeline must change. The formation rules must change. The assumptions baked into a century of cosmology must change. Because Webb's observations whisper a message that is both thrilling and terrifying. We were not wrong about the galaxies. We were wrong about the beginning. We may be living inside an eternal universe, one far older, far stranger, and far deeper than the Big Bang ever allowed us to